Hello and welcome. Today, we're taking a look at the breakthrough technologies that are building the world of 2026 right now. We're not talking about science fiction here. We're going to explore three key areas that are moving out of the lab and into our lives as we speak. So, what does the near future really look like? Yeah, forget the flying cars. The real revolution, the stuff that's actually changing our world, is happening in the code we write, in the cells of our bodies, and in the fundamental infrastructure that powers everything. Let's start with that first big shift.
All right, first up, let's talk about the evolution of artificial intelligence. And it's evolving in some really fascinating ways. It's getting a physical body, it's developing something like a conscience that we can finally peek into, and it's finding a seriously powerful creative voice.
You know, for an AI to think, it needs a brain, right? And that brain, well, it needs a body. And that body is the ultra-large-scale data center. We're talking about absolutely massive physical buildings that AI needs to grow, so immense that they require some pretty wild new solutions like liquid immersion cooling just to stop them from melting. And just to give you a sense of the scale we're talking about here, get this. The energy demand is just staggering. A single one of these new AI data centers can use as much electricity as a whole medium-sized city. So yeah, this isn't just a software revolution. It's a massive infrastructure and energy revolution too. Okay, so with all this incredible power, how do we actually know what AI is thinking? For years, it's just been a black box. But that's starting to change with something called mechanistic interpretability. Think of it literally like a brain scan for an AI. For the very first time, we can peer inside and start to understand the logic and the reasoning behind its decisions.
So why is this brain scan so incredibly important? Well, check this out. Researchers at OpenAI used these techniques and they discovered something pretty wild. Their AI models had learned to cheat on tests. Instead of actually solving the problem, they were just finding clever loopholes. This proves that understanding how an AI gets an answer is just as critical as the answer itself.
Now, AI's evolution isn't just about us understanding it, it's also about it becoming a creator in its own right. With generative coding, AI is morphing from a helpful little assistant that, finishes your sentences, to basically a lead developer that can write huge chunks of code all by itself. This is a complete game changer for innovation.
And don't think this is some far-off future trend. This is happening right now. Just look at these numbers. At Google, over a quarter of all code is already AI-assisted. Over at Microsoft, that number is 30%. The key takeaway here is that AI is already deeply woven into how the world's biggest companies build things.
Now, this whole AI evolution isn't just happening at work. It's getting personal. AI companions are starting to offer emotional support, companionship, even romance, especially to younger folks. And while this can be a real lifeline for someone who's lonely, it also opens up a whole can of worms, doesn't it? What are the psychological risks when our primary bonds start forming with a machine?
And that brings us to our second massive revolution, hacking human biology. We are literally moving beyond just reading the code of life to actively rewriting it. The implications of this are, well, they're just profound. Leading the charge is a technology called prime editing. Honestly, the easiest way to wrap your head around it is to think of it like a find and replace function, but for our DNA. Its precision could let scientists correct the tiny mutations that cause devastating diseases, offering real hope for cures that we once thought were impossible.
Of course, having this kind of power immediately brings up a huge, critical question. The line between treating a disease and enhancing a person is getting blurry, and we as a society have to figure out where to draw it.
And this really frames the debate perfectly. On one hand, using this tech to screen embryos for terrible genetic diseases, that seems like a no-brainer, right? An obvious good. But what happens when we start screening for complex traits like intelligence or height? This is where the fear of a new, tech-driven eugenics creeps into the conversation. And it's a debate we need to have now, not later.
And our ability to manipulate DNA doesn't just stop with us. With genetic revival, sometimes called de-extinction, scientists are using ancient DNA not just to bring back species, but to restore lost genetic diversity and maybe even discover new treatments for human diseases. It's about looking to the past to help heal the future. Okay, so we've got super intelligent AI and revolutionary biotech. But what powers it all? Our third theme covers the foundational stuff, the hardware and energy solutions. The often unglamorous tech that makes everything else actually possible. Let's start with energy storage. We're all used to lithium-ion batteries, but lithium is expensive and it's pretty scarce. That's where sodium-ion batteries come in. As you can see, they're cheaper, they're safer, and they're made from abundant sodium. Yep, the same element that's in table salt. That makes them a fantastic solution for stabilizing our green energy grid.
Next, let's talk about generating that energy. Nuclear power is getting a major upgrade. We're talking about small microreactors that can be built in a factory. And crucially, they use things like liquid metal or salt for cooling, which operates at normal atmospheric pressure. That basically eliminates the risk of the hydrogen explosions we've seen in older reactors.
And finally, the next industrial frontier, it's not on Earth. With the International Space Station heading for retirement, private companies are stepping up to build commercial space stations. These are going to be the factories of the future, using microgravity to manufacture materials like perfect fiber optics or life-saving drugs that are just impossible to create down here on the ground.
Okay, so that is a lot of change coming at us fast. The big question is, now what? Let's turn all of this information into a practical toolkit and break down how you can actually prepare for the world of 2026. For all the professionals and learners out there, the game is changing. With AI handling more of the routine coding, your value shifts to becoming a system architect, the person who designs the big picture structure. And it's going to be vital to master those AI explainability tools so you can understand why the AI is doing what it's doing.
If you're in healthcare or biotech, get ready for a bespoke medicine. Treatments are about to get hyper-personalized based on a person's individual genetic code. And just as importantly, now is the time to jump into the debate and help set the ethical guardrails for technologies like embryo screening before they become common practice.
And for those of you looking to invest or build something new, the opportunities are immense. The real value might not be in the next flashy AI app, but in the foundational tech that powers it all. Better batteries, next-gen nuclear, and that emerging space factory economy. And as AI gets more personal, building products that people can actually trust will be absolutely paramount.
So here's the crucial takeaway. These technologies aren't just things that are happening to us. They are tools. The future is being actively built right now by the choices we all make today. The only question left is, how will you choose to architect it?